Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. This one question lost more marks than any other on last year's papers. Students were asked to solve a simple quadratic inequality, and many either lost a mark for the answer format or forgot to test the intervals. Sound familiar? You need this episode if you want those easy marks back.
Ouch, I probably lost marks there. What exactly will we cover?
Promise and roadmap. We'll cover one focused thing today, solving and sketching linear and quadratic inequalities. First, a quick refresher on linear inequalities and the sign flip rule. Then a deep dive into quadratics, finding critical values, making a sign diagram, and turning that into a clean number line sketch and interval answer. Finally, I'll show the exact marks examiners give and a 10-second check that catches most careless errors. Let's work through this step by step.
Section. The concept. Start simple. Linear inequality. Example, solve 3x minus 7 less than 5. You collect like terms, 3x less than 12, then divide by 3 to get x less than 4. Easy. The only time you must change the inequality direction is when you multiply or divide by a negative number. For example, if minus 2x greater than 6, then dividing by minus 2 gives x less than minus 3. Note the flip. Don't skip that note, it's where marks go missing.
Right. Flip the sign when you divide by a negative. I always forget that under pressure. Now, the quadratic step-by-step. Take a typical higher-tier question. Solve x squared minus x minus 6 greater than 0. Step 1. Find the critical values. Solve x squared minus x minus 6 equals 0. Factor the quadratic. X minus 3 times x plus 2 equals 0. So critical points are x equals 3 and x equals minus 2. These roots partition the number line into 3 intervals, x less than minus 2 less than x less than 3, and x greater than 3. Step 2. Pick a test value in each interval and evaluate the sign of the quadratic. That tells you where the expression is positive, negative, or 0.
Let's test. For x less than minus 2, pick x equals minus 3. Plug into x minus 3 times x plus 2. Minus 6 times minus 1 equals plus 6, positive. For minus 2 less than x less than 3, pick x equals 0, gives minus 3 times 2 equals minus 6, negative. For x greater than 3, pick x equals 4, gives 1 times 6 equals plus 6, positive. So the quadratic is greater than or equal to 0 when x less than or equal to minus 2 or x greater than 3. Wait, subtlety. Our tests showed positive on the outer intervals and negative in the middle, and at the roots the expression equals 0. Because the inequality is greater than or equal to 0, we include the roots. So final answer in interval notation is minus infinity minus 2 union 3 infinity. Write it clearly and show the filled circles on the number line for minus 2 and 3.
So factor, find roots, test intervals, and remember whether to include the roots. Got it. But why does this sign behaviour happen?
Good question. The roots are where the expression equals 0. Between roots, the factors each keep their sign until they pass a root where one factor changes sign. For x minus 3, x plus 2, the sign of each factor flips at its corresponding root, so the product flips sign when you cross any root. Roots partition the number line. Signs are constant on each partition. Let that sink in. It's the core reason tests work.
Section. The exam technique. Here's where the marks are. For a typical 3-mark quadratic inequality question, examiners look for 3 things. M1 for correct critical values, showing the factorization or using the quadratic formula, M1 for a correct sign test or clear sign diagram, and A1 for the correct final answer in the requested format.
If you miss the sign test but write the correct interval, you might still lose a method mark, so always show your test or a labelled number. That's where write it down, don't just think it comes in.
What about equality and endpoints? Do examiners expect open or closed circles?
Include endpoints for greater than or equal to or less than or equal to with closed circles and square brackets in interval notation. Use open circles and round brackets for greater than or less than. Common trap, shading the wrong side of the number line or using round brackets for less than or equal to. That loses marks immediately. Also, write your working in the order the examiner expects, factor or solve equality, list critical values, show testing or sign diagram, then state final answer clearly. Often you can earn method marks even if the final arithmetic is messy.
Section, the quick win. A 10-second habit that saves marks every time. Substitute one value from your final answer back into the original inequality. If your final answer says x greater than or equal to 3, pick x equals 3 and x equals 4 and substitute them to check the inequality holds. Memory trick, CTS, critical points, test intervals, state answer. Write CTS in the margin of every inequality question and follow those 3 steps.
Substitute back. I can do that on any question. Anything else quick I can use?
Yes, always mark the roots on the number line and annotate their signs underneath, plus or minus. One neat trick, when factors are linear and distinct, you can decide the outer intervals are the same sign. That speeds testing. If leftmost test is positive, rightmost will be positive too. That's a grade 9 move for speed, but only use it after you know the basics.
Worked example walkthrough, full GCSE style question. Solve and sketch the solution set for x minus 2 into x plus 3 greater than 0. Step 1. Critical values x equals 2 and x equals minus 3 by setting each factor to 0. Step 2. Partition x less than minus 3, minus 3 less than x less than 2, x greater than 2. Test x equals minus 4 gives minus 6 into minus 1 equals plus 6, positive. Test x equals 0 gives minus 2 into 3 equals minus 6, negative. Test x equals 3 gives 1 into 6 equals plus 6, positive. Inequality is greater than 0, so we exclude roots. Final answer, minus infinity, minus 3, union 2, infinity. On the mark scheme, this earns M1 for roots, M1 for sign test or diagram, A1 for final interval.
Exactly. Include the roots for greater than or less than. Don't forget to show the circles filled in on a sketch, or write square brackets in interval notation. That's exactly what the examiner looks for.
Practice prompt. Try these now. Question 1. Solve 2x plus 1 less than or equal to 7. Question 2. Solve x squared minus 4x plus 3 less than 0. Pause the episode, work them out, then check your answers. Marking hints. For Q1, you'll show one linear rearrangement and the final inequality, one method mark and one accuracy mark. For Q2, factor to x minus 1 times x minus 3, get roots 1 and 3, test intervals and state final answer 1, 3. If you followed CTS, you'll get full marks.
I'll try them now. Nice to have the marking hints so I know what to write down.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.